identify the type of connection the following resistors have with the other resistors. So the first thing I asked you guys to do is identify the important nodes. So we have R2, R3 and R1 connected at two different nodes, A and B. Now think over what is the type of connection between the respective resistance. I hope you guys did. R1 and R2 are parallel to each other, right? Because whatever electrons goes through R2 will just go through this point, but not go through R1. Is it not? Whatever goes to R1, right, starts from here, goes that way and goes out. Then whatever goes through R3 will not go through anything else. It will just go to node B and it will go out, right? So something like this. Make sense? So since they don't share the same current or any current, right? So we have all of them to be parallel to each other. R3 parallel to each other. Next question is this circuit 2. I would like you guys to figure out which is series and which is in parallel. So this is where the tricky question starts from. First thing first, we'll identify the important nodes. So R3 and R1 are connected at node A. Then R3 and R2 are connected at, say, node C. And R1 and R2 are connected at node B. I hope you guys identify three nodes. Now, which electrons will go where? Say a bunch of electrons. They'll get divided over here. Make sense? And few of them will go here and pass through node C and out. We have few more electrons, say here, that will go over there, going through R1 and even R2 and out at node C. Now the question is, which is in series, which is in parallel? First, we will begin with R1 and R2. They are in series, right? Same bunch of electrons going through them, they are in series. The next one is what we have to understand very clearly. Combination of R1 and R2 and R3. So this as a whole, right? So this as a whole is in series with R3, sorry, parallel with R3. So the combination of R1 and R2 and R3 are parallel with each other. So we can tell equivalent resistance of R1 and R2, right? Or you need not write so much. We'll shorten the, yeah, something like this. The equivalent resistance of R1 and R2 is parallel to R3. So we need to understand how to find equivalent resistance, but I hope you guys understand the term equivalent resistance. It's similar to equivalent resistive path. That is, you're replacing this 2 with a single resistor. Anyways, we'll see that in detail again. So I hope you guys got this.